All right, so we looked at why 1 is true, and I talked a little bit about how 2 is just the reverse of what we proved. But let's take a look at row equal 1. This is really easy to prove because all you have to do to prove something's inconclusive is show that there's a case where row equals 1 is a convergent series and a case where row equal 1 is a divergent series. So if row equal 1 can be either one, then that means it's an inconclusive test. And the perfect thing to show that with is a p-series. And there's a good reason for that. So imagine the p-series 1 over n. So we know that's a divergent p-series. P is 1, which is less than or equal to 1. But if we calculate our row, look at that ratio. We have an indeterminate form. I'm just going to do our standard algebra, divide top and bottom by n. So that limit comes out to be 1. So that was a divergent series, and the row came out to be 1. But let's just do a convergent p-series. So say you had 1 over n squared. That's a convergent p-series. P is 2, which is bigger than 1. But if we calculate our row, limit as n goes to infinity of that. So I'll flip it, and again, we have an indeterminate form, infinity over infinity. I'll divide both top and bottom by n squared. That also equals 1. So any p-series, actually, the row comes out to be 1, whether it's convergent or divergent. So it's a perfect example of why row equal 1 is inconclusive. Now, this hints at something, though. Because p-series do always come out to be 1, what you'll often find is if you try and do the ratio test on some series and row comes out to be 1, either you actually had a p-series and you just didn't notice it. Sometimes people will see a series like 1 over n square root of n or something, and because it's written with roots, they don't notice that, oh, that's a p-series. But you could just sort of not catch that and go, oh, I'll do ratio. And if you come out to be 1, the thought that should go through your head is, do I actually have a p-series and I just didn't catch it? Or what also will often happen is if it comes out to be 1 when you do the ratio test, what you really have is something that you should have done either a direct comparison or a limit comparison test with a p-series. So when this happens, when you get a row of 1, all is not lost. The first thing you should start thinking is, OK, do I have a p-series, or do I have something close to a p-series that I could do DCT or LCT with? So keep that in mind when this does happen.